So we wanted to do a study that would ask about what was going on during this 2-month interval that it took to shift from the control state to the calorie restricted state. We thought it would be interesting to see how many of the genes that are like long-term calorie restricted gene changes would be recapitulated in just that interval that it took to start the anti-cancer life-extending effects. And so we did an experiment with old mice. These 33-month-old mice are very old mice. We had a control group that had eaten almost all they wanted their whole life. They weren't obese. Some that were restricted for 2 weeks, that had eaten almost all they wanted their whole life, but now they were restricted for 2 weeks or 4 weeks or 8 weeks, or had been lifelong calorie restricted, or were lifelong calorie restricted and then were shifted to control feeding for just 8 weeks. So we wanted to look at the transition back. And here's some of the results we got. Well, let's not look at these ones because they're a little more complicated to interpret. The simple case is over here, and most of the genes are in the simple case. And that is, if you switch to CR for 2 weeks or 4 weeks or 8 weeks, you saw a gradual turnover of genes from the control level of expression to the level of expression that they had after a lifetime of CR. Now, there were some genes that took longer than 8 weeks to change, clearly, because they were changed by lifelong CR, but not by 8 weeks of CR. So not everything changed, but the vast majority of them changed. And then, interestingly, even these genes that took longer than 8 weeks to change, all of them changed back to control levels. Even after a lifetime at these levels, in 8 weeks of control feeding, they would shift back. So it goes away as fast, even faster maybe than it comes. So we were very interested and continue to be interested in these genes because these are the guys that are diagnostic of that period of time when you go from control to the anti-cancer effects. And I just wanted to show you too, there's programs you can take these big lists of genes and put into, and actually some of them will do statistics for you depending on their level of expression. And here are the sort of, up here are the regulators that we saw changes in. So we saw gene expression changes that were consistent with signaling through the FGF2 pathway, through the insulin pathway certainly, through the EGF receptor pathway, NGF, and also TNF, decreased signaling through the TNF pathway. So those are the kinds of signal transduction pathways in the liver that we see being affected. So we saw rapid changes, as I've told you, and this also implies that these gene expression changes may be either an effect of a physiological effect of calorie restriction, or they may even be the cause of the improved health and anti-cancer effects. We can't distinguish whether they're cause or effect, but there's certainly one of those because they're closely linked to calorie restriction. We run through some of them. There's the Vallejo nursing home study that seemed to show that every other day, either an every other day fasting regimen or just a CR regimen, it's not clear which, caused fewer deaths, although it wasn't statistically significant, but less time in the infirmary, and that was statistically significant. And then there's the famous Okinawan study where they have a lower incidence of diseases, more centenarians and healthier than the rest of Japan. They also eat less. There's Walford's biosphere study, I'm sure you're familiar with. And Roth's George Roth took the data from the Baltimore longitudinal study and reanalyzed it and looked at the longest lived quatrile versus the shortest lived quatrile, and he found that the longest lived quatrile was associated with lower insulin levels, that is more insulin sensitivity, and then lower body temperature and also higher DHEA levels. And probably DHEA decreases with age, and probably that was indices of how fast these people were biologically aging. And then you're very familiar with these studies, I know, the Fontana-Halsey studies. Eric Ravison just published the study from the Calorie study funded by NIH. Unfortunately, his biggest conclusions were that CR reduced fasting insulin body temperature and metabolic rate, and we kind of already knew that. So hopefully there'll be more coming out of that. I know they're working on measuring gene expression in some tissues they've taken. And there's also this Mayo Clinic health study that says that just losing 5 to 10% of your body weight improves all these indices of lifespan and survival. Mike?
I can't think what the
What the what study?
I don't remember.
Yeah, it's in the literature. I'd be happy, email me and I'll email you the reference. It was a little hard for me to find, but it's out there.
With the subjects overweight or diabetic?
Yeah, I think they looked at all of the subjects that had come through their hospital. But I'm not really good at these sort of demographic statistical analysis studies. You could take a look at it. That takes a whole level of math I just can't get to. So this is where you're going to start throwing things at me. I felt like a rock star last night. Now I'm going to feel like somebody's out to get me. So we're not nematodes, flies, mice, rats, or dogs in a vivarium. At the NIA Rhesus study, the CRs recently have more mortality than the controls. Now there are many potential explanations for that. You know, the CR and the controls are eating almost the same amount now because they're in these little cages. They've lost interest in their food. They throw the food away. The keepers have to pick it up and put it back in their bins, and it's difficult to tell. Even the CRs don't eat all of their food. And some of them go into this thing where they just get depressed and stop eating altogether, and they have to start feeding them candy and give them more attention to get them reinterested in life. So they've taken these very smart primates and put them in tiny little cages in a very, very boring environment, and so there are a lot of issues here. But more importantly, human demographic studies don't support, and this really concerns me. So this is a study, there's the reference. I'd love to have some people take a look at this study. So they analyzed using a different model slightly than in order to parse out some of the different effects. So you've certainly seen this U-shaped curve for body BMI versus probability of death. And so it decreases and then goes up for higher BMIs and up for lower BMIs. Now, Roy Walford used to criticize this because he would say down here, you weren't removing the people who are going to die from disease and who had thinned out for that reason, or smokers and all. And so certainly the demographers have started to correct for all of that and make models that are very sophisticated. These guys even parsed out cardiovascular disease definitely in men goes up with BMI. With women, not so much, surprisingly. Neoplasm for men stays pretty flat with BMI. With women, higher BMI, it goes up slightly. But take a look at other here. Death due to other is really the reason for this upturn. So you may improve your chances of dying of cancer and heart disease, but it looks like you're increasing your chances of dying from other. And so you say, well, what is other? And these guys obviously aren't economics and human biology. I don't know if they're doctors. They're certainly data crunchers. They called it organic disease and infectious disease. And so so infectious disease I understand because CR can repress the immune response. But organic diseases, things like gastric ulcers, arthritis, inflammation, that doesn't make quite sense because inflammation definitely goes down. Infections, certainly emphysema, multiple sclerosis, ALS, things like that. So we know that very low fat diets can do permanent neurological damage. So there it is.
Well, it makes sense to me that
So just a moment ago, you said that low-fat diets are known to cause neurological damage, and I've long
They're extreme diets.
okay, because I've long hypothesized that would be, and you seem to see it in people taking statins. There's an increased risk of starts with a P, polyneuropathy, but I didn't know that this was sort of a known fact.
These are animal studies.
Okay.
And there is a literature in animals of being able to create permanent neurological changes and I can't remember if they're rats or mice, if you keep them on an extremely low-fat diet for a while. Yeah, I'd have to go back and try to find them, but sure, I'd be happy to.
Steve, these studies were all done in ad lib people, right? They weren't done in CR people.
Yeah, so I think this is either the Framingham study or the physician, that physician and nurses health
That's the
study.
first thing I'd like to point out. This was done in an ad lib population.
Yes,
Okay,
yes.
if I'm a healthy person in an ad lib population, I guarantee you I'm going to eat all that I can. So the healthiest people ate as much as they could.
Well-
So the healthiest people live, they didn't show the mortality there.
Well, I think that's related to the comment we just heard, is that that you've got genetic people
all
that are
mixed together.
lighter because they're genetically.
So this says nothing
yes.
about CR, because this is in an ad lib population where the healthy people ate a lot because they could.
Another interesting point.
So I claim that if you're healthy, you'll be fat and overweight. And if you're not
Good, I'm
healthy, you'll be
healthy.
squinny because you can eat a lot. You
Praise
can't
God,
carry
I'm
that way.
healthy.
Healthy people will be overweight. You should be overweight for yourself because
Yeah.
you're enjoying life.
So I've been really worried about this, so I'm happy to hear this argument, actually.
Well,
I appreciate it.
We worked with the inbred strain, and it was only males of the F344 rat. And we asked, when we first started our work, it was many years ago, we asked the question, really, did all this thing work because of changing body fat? And so we measured body fat throughout the life. And what we found with the ad libitum animals, they had a range of fat. It didn't make any difference how fat they were. That wasn't what was controlling how long they lived, clearly. So there was no relationship between how fat the ad lib animals were and how long they lived. Now, we have to point out to you that the Fisher 344 rat does not get fat. It's a fairly lean rat, so we weren't dealing with obesity. When we looked at the restricted animals, they also had a range of fat. And they all ate the same amount of food, but they still had a range of fat, and they had the same genes, but they still had a range of fat. And the answer was that the thinner they were, the less fat they had, the shorter they lived.
Interesting. Okay, great. Well, let's move on. This has been very interesting for me.